Okay, I want to talk about a really common mistake I've seen students make when it comes to talking about Beer's law and molar absorptivity. Here's the question. What will cause a change in molar absorptivity? And I think of this problem as a really straightforward, easy problem. It's definitional. You know the definition of molar absorptivity, you know how it's defined, you're done. The problem is, most students go to the mathematics and they say, well, A equals epsilon BC, path length, concentration, absorbance, and then they rearrange. And they say, well, very easily, epsilon is equal to A over BC. So if absorption, concentration, or path length change, epsilon changes. And this is mathematically correct, but not true. What's the right way to say this? It's not scientifically, it's not physically correct. And we've got a kind of easy way that we can reconsider this. So path length, as we know, is controlled by the size of the cuvette. We have some situation there. So we can just think about this in terms of path length is equal to absorption divided by epsilon times concentration. This, mathematically, would suggest that if we change the concentration, our cuvette would grow and shrink. Right? And we know that doesn't happen. Path length, when we were using this in class, path length was always 1 centimeter. It was set by a physical constraint of the system. So when we go back and look at Beer's law correctly, we can see that this B, that path length, was essentially a choice we made, an experimental choice, if I could spell. It was an experimental choice. We could have gotten a different setup and had something with a really big opening, and then we would have had a longer path length. But we were using those cuvettes, those things that were 1 centimeter wide, and so our path length was set. The rearrangement, path length doesn't change with concentration or absorbance. And it turns out that epsilon is also a parameter set by physical reality, not just by the mathematics. This is set by the chemical compound. Epsilon is the parameter that is dependent on the chemical compound we're looking at. So if we're considering blue dye versus yellow dye versus nickel solution, whatever we're looking at, epsilon is going to be the thing that changes based on the chemical compound we're looking at and by the wavelength of observation. And that's by definition, right? Remember, Beer's law was originally created by saying that there's some proportionality between concentration and absorption. So we have to think about these equations in chemistry not as mathematical equations where we can just rearrange it any way we want, but we have to think about how the equation represents something in physical space, how the equation represents something chemical, something in the real world, and how we can use our knowledge of the real world to tell us about the different parameters, and then how those parameters can also inform us about the chemical system we're looking at. Right? We always have to go, one of the big problems in chemistry is real stuff. It's not just equations. So we have to think about what each variable means. If you're feeling a little lost in this, go back, watch the video where I define everything in Beer's law. But this is a really common mistake. This is set by the chemical system. This is set by an experimental choice. They don't change with absorption and concentration.